So if you spent like $10 million training a frontier AI model this morning, congratulations. By this afternoon, you're already losing to a competitor who spent a fraction of that.
Right, because they actually know how to plug it into their company's data.
Exactly. I mean, it is a brutal reality check for the industry right now.
It really is. Intelligence itself is, it's rapidly becoming a commodity, you know? The real differentiator now is execution.
Well, welcome to this deep dive, everyone. Our mission today is to explore this massive, just structural pivot happening across the tech world right now.
Yeah, a total paradigm shift.
For the past 2 years, the only question that dominated boardrooms was, who has the smartest model? But as of this week, July 2026, that question is officially obsolete.
Completely obsolete.
Right. We are officially transitioning from the era of AI capability to what we're calling the era of AI advantage.
Or as the sources we're pulling from today describe it, the execution economy.
The execution economy. I love that term. And to map this out for you, we are looking at a highly specific stack of intelligence today.
Yeah, we're diving into multiple editions of the July 2026, your weekly AI pulse reports.
We're synthesizing their leadership editions, their deep dives, and even the visual architectures they've published to really explain this shift.
There's a lot of material to cover, but it all points to this one central theme.
Okay, so let's unpack this for you. Imagine the last 2 years of AI development like the invention of electricity.
That's a great way to look at it.
Right. Like the entire industry was completely obsessed with building the biggest, most powerful generator. Everyone was staring at the raw wattage, just amazed by the benchmarks.
And, arguing over whose generator was slightly louder.
Exactly. But suddenly, we're in the phase where the winners are the ones who actually know how to wire the house, install the outlets, and, actually turn the lights on.
Because a massive generator sitting in an empty field does absolutely nothing for you.
Right. The technology doesn't win on its own anymore.
Yeah.
The operational system around the technology does.
And to understand how organizations are actually, wiring the house, we need to examine 3 distinct shifts laid out in the Pulse reports today.
Let's hear them.
First, infrastructure economics. So how the physical compute grid is evolving. Second, organizational readiness, which is all about how businesses are proving the financial return on this stuff.
Which is huge right now.
Oh, massive. And third, global regionalization. How AI integrates into a deeply fragmented global market.
So if we want to understand how to wire the house, we have to start by looking at the grid itself, right? The underlying hardware and cloud infrastructure.
Right, the physical layer.
For a long time, hardware announcements were basically just speed tests.
Yeah.
There's always a tech CEO holding up a chip and saying, look at how many teraflops we squeezed into this silicon.
Yeah, just pure horsepower.
But the sources are pointing to a completely different metric now, specifically highlighting NVIDIA's new Vera Rubin platform.
Yeah, and the shift in NVIDIA's strategy here it's fundamental. They are no longer just selling a faster processing chip.
What are they doing instead?
The Vera Rubin platform is about optimizing the entire full stack. So they're taking the compute processors, the networking switches, the memory bandwidth, and the orchestration software, and unifying them into one single optimized platform.
Wait, I want to pause on that because it sounds like standard tech marketing jargon.
Yeah.
Right? Unifying the full stack.
It does sound like a buzzword.
Yeah. Like, why does combining the memory and the networking physically matter to the AI? What is the actual bottleneck they're trying to solve here?
Okay, so it really comes down to traffic jams. When you are running a massive AI model, the processor itself is incredibly fast. It's like a sports car.
Okay, sport car.
But the data it needs to process is stored in memory, which acts like a warehouse. Historically, the connection between the warehouse and the sports car was a narrow, one-lane dirt road.
Ah, I see.
So the processor spends half its time just sitting idle, literally waiting for data to travel over the network.
Which is incredibly inefficient.
Exactly. So by unifying the compute, the memory, and the networking switches, NVIDIA is essentially building a 10-lane superhighway directly from the warehouse to the engine. They're eliminating the traffic jam.
Which means you aren't paying for a chip to just sit idle while it waits for data.
Right.
Which leads perfectly into the phrase the sources keep emphasizing today. We are entering the intelligence per dollar era.
Intelligence per dollar, that is the metric that matters now.
The industry benchmark isn't about peak speed anymore. It's about how much actual AI reasoning you can extract for every dollar you spend on electricity and infrastructure.
Precisely.
But let me push back a bit here, because wasn't cloud hosting always about keeping costs down? I mean, optimizing server costs is practically a religion in Silicon Valley.
Oh, absolutely.
So what makes AI infrastructure fundamentally different from running like a traditional SaaS application?
Well, think about the mechanics of a traditional cloud application. You write the code, you compile it, you host it on a server, and it just waits for a user to click a button.
Right. The compute cost is highly predictable and pretty low.
Exactly. But AI compute is entirely different because of what the sources call post-training workloads.
Meaning all the computation that happens after the initial model is built and launched?
Yeah. The initial training, feeding the AI half the internet over 6 months is incredibly expensive. We all knew that.
Yeah.
But the industry used to think that once the model was trained, running it would be cheap. That assumption has completely collapsed.
Really?
Yeah. Modern frontier models are continuously running processes like reinforcement learning and reasoning inference just to answer your questions.
Okay, let's define those mechanisms for you listening.
Yeah.
What is actually happening inside the servers during reasoning inference that burns so much cache?
So when you ask a traditional model a question, it just predicts the next most likely word and spits out an answer instantly.
Like autocomplete on steroids.
Exactly. But advanced reasoning models are designed to think before they speak. If you give the AI a complex coding problem, it doesn't just write the code.
What does it do?
Internally, it generates a hypothesis, writes a draft, tests that draft against a simulated environment, realizes it made an error, discards the draft, and tries another pathway.
Wow.
It might simulate thousands of trial and error pathways in the background before it ever shows you the first line of text.
So it's basically playing out a massive, multidimensional chess game against itself just to answer a single prompt.
Yes. And that background simulation requires a staggering, sustained amount of computation on the fly. You cannot just buy a fast chip once and call it a day.
It's ongoing burn rate.
Exactly.
Yeah.
Operating the model day to day is becoming just as expensive as creating it in the first place.
Which is wild.
It is. And this is why infrastructure is no longer just a line item on an IT budget. If your infrastructure is inefficient, you literally cannot afford to operate the smartest models at scale.
Your profit margins will just evaporate.
Completely.
And this realization that compute is the ultimate bottleneck, it extends way beyond corporate tech giants, right? The sources highlight this massive surge in what they call sovereign AI.
Yes. Governments and national initiatives, alongside private sector heavyweights like SpaceX, are aggressively investing in secure, localized compute.
They aren't looking at data centers as IT facilities anymore.
No, they're viewing them as strategic geopolitical assets. We are seeing a race to build national infrastructure grids specifically for AI.
Because if a country's entire economic output and defense logistics rely on reasoning inference, they can't have their data pipeline running through a server rack halfway across the world, right?
Exactly. Vulnerable to foreign surveillance or latency. Data locality is security now.
So compute is essentially the new domestic steel industry. But this creates an incredible tension. If operating these models requires national grid levels of investment, the CFOs and the corporate boards are going to start demanding receipts.
Oh, they already are.
How do you justify that electric bill?
Well, that tension forces us into the second major shift the sources identify: organizational readiness.
Let's get into it.
For the past 2 years, companies were perfectly happy to treat AI as this fun research experiment. They would buy 10,000 Copilot licenses, hand them out to employees, and track user adoption.
Right, I've seen those dashboards. An executive points to a chart showing that prompt volumes are up 400% this quarter, and everyone claps.
Yeah, exactly.
But half those prompts were employees asking the AI to write a haiku for their colleague's birthday. The adoption metrics look incredible, but the actual financial value generated for the company is zero.
Zero. Which is why OpenAI is aggressively pushing enterprises to abandon those vanity metrics entirely.
What are they replacing them with?
They just released a new playbook called the AI Scorecard, and it fundamentally changes the definition of success. OpenAI is telling their own enterprise clients to stop measuring how many people use the software and start measuring organizational maturity.
Organizational maturity, right.
They want companies to evaluate leadership alignment, security governance, and most importantly, concrete business outcomes.
It's the difference between tracking how many of your employees bought gym memberships versus actually measuring if their cholesterol dropped.
That is a perfect analogy. The board doesn't care about the gym membership. They want bottom line financial impact.
And we are finally getting the tools to measure that cholesterol, so to speak.
Yes, we are.
The sources point to a highly specific rollout from GitHub that illustrates this perfectly. They've introduced repository-level Copilot metrics.
This is a huge deal.
Engineering managers no longer track how many lines of code the AI generated. Instead, they are tracking how the AI impacts the entire software lifecycle at the repository level.
Right.
So break down what that actually looks like in practice for an engineering team.
Okay, imagine you're running a software team. With these new metrics, you can look at a specific internal project and see the data proving that since integrating AI, your release velocity.
Meaning the time it takes to get a new feature from a laptop to a customer.
Exactly. You can see that time has dropped from, say, 14 days to 9 days.
Yeah.
Furthermore, you can see that the number of bug tickets filed after a release has decreased by 15%.
Okay, see, that is no longer an AI metric. That is a core operational efficiency metric.
Exactly.
You can take a 15% reduction in bug fixes and a 5-day faster release cycle directly to the CFO and calculate the exact dollar amount saved in engineering hours.
And that is how you justify the infrastructure bill.
Right.
But there is a secondary challenge here. If every company in the world buys the exact same frontier model from OpenAI or Anthropic, and they all achieve a 15% efficiency gain.
Then nobody actually has a competitive advantage.
Exactly. The baseline just moved up for everyone.
Right. If everyone has the same superpower, it's
Yeah.
just a normal capability. So how does a company actually create an advantage out of a commoditized model?
By heavily customizing it with proprietary institutional knowledge, generic AI is just no longer enough to win in the execution economy.
Okay, how are they doing that?
The sources highlight GitHub rolling out customizable code reviews as a prime example here. You can now configure the AI to evaluate code based on your company's highly specific internal architectural standards rather than just general internet best practices.
Oh, that's interesting. So if a junior developer tries to push a piece of code, the AI doesn't just say, this code looks functionally correct.
Right.
It says this code is functionally correct, but it violates the specific database security policy we established internally last year, so I am flagging it.
Precisely. It acts as a senior engineer who has 10 years of institutional context at your specific firm.
That's incredibly powerful.
It is. And the barrier to creating these customized models is collapsing too. The sources highlight a major partnership between NVIDIA and Hugging Face designed specifically to simplify fine-tuning.
Okay, let's explain fine-tuning for you listening, because it's a term that gets thrown around a lot.
Mm-hmm.
What does this partnership actually allow a company to do?
Historically, if you wanted an AI that deeply understood your proprietary data, you had to build a foundation model from scratch. Which cost tens of millions of dollars.
It requires a team of PhDs. Fine-tuning changes all of that. You take a highly capable open-source model that already knows how to read, write, and reason.
You aren't building a brain from scratch.
Exactly. You are taking a smart brain and sending it to medical school, or in this case, sending it to your company's internal knowledge base.
Got it.
The NVIDIA and Hugging Face partnership provides the optimized infrastructure and software tools to make that process cheap, fast, and accessible to non-AI specialists.
Okay, so let's connect the dots here. We have the efficient infrastructure grid making compute affordable.
Yep.
We have the internal readiness, moving past vanity metrics to measure real ROI.
Exactly.
And we are fine-tuning the models on our own proprietary data. But there is still a massive missing link for me.
What's that?
Even a highly customized model is usually just sitting in a chat interface on a web browser. Like, how does the AI actually touch the live data? How does it break out of the box and actually do the work? This is perhaps the most critical technical shift in the entire deep dive today. The sources point to a framework called the Model Context Protocol, or MCP.
MCP. Okay, I have to play the skeptic here for a second.
Go for it.
MCP just sounds like another API integration. Tech companies have been promising seamless API integration for 20 years. What makes the Model Context Protocol fundamentally different from the software plugins we already use every day?
It's all about friction. The friction of traditional APIs is the difference. If you want a traditional chatbot to talk to your inventory database, a software engineer has to write custom glue code.
Right.
They have to establish specific, hard-coded API endpoints and manually define exactly what data the bot is allowed to ask for. It is brittle and it constantly breaks.
It's a nightmare to maintain.
Exactly.
Yeah.
MCP completely standardizes how an AI agent connects to data sources. It provides a secure, universal interface that allows the AI to independently negotiate and query the enterprise databases it needs to establish context.
Independently.
Yes, all while respecting your existing enterprise access controls.
So it's not a hard-coded script. The AI can dynamically realize, I need to check the inventory levels to answer this user's question,
Uh-huh.
and it uses the MCP to securely fetch that exact context in real time.
Yes. The sources use the specific example of Smartsheet running a remote MCP server on AWS. This transitions the AI from being a conversational chatbot into a connected operational actor.
A connected operational actor. Give me a real-world scenario of that in action.
Okay, imagine a supply chain manager tracking a massive shipment. Without MCP, the manager asks the AI, how do I update a delayed shipment? And the AI spits out a generic tutorial on how to use the database.
Not very helpful.
Right. With MCP, the AI securely connects to the live database, cross-references an incoming email from the freight supplier, and says, I see the cargo ship is delayed by 3 days. I have already drafted the updated timelines in Smartsheet and queued up the notification emails to the regional distributors. Would you like me to execute this workflow?
Wow. It doesn't just tell you how to do the work, it literally does the work.
Exactly.
And this explains why Microsoft is embedding Copilot so aggressively deep into Azure and the Microsoft 365 ecosystem. The strategic differentiator isn't having the model with the highest SAT score.
No, not at all.
The differentiator is having the AI living natively inside the security frameworks, the spreadsheets, and the cloud infrastructure the enterprise already uses.
Because an isolated model, no matter how intelligent it is operationally useless. It has to act on the data where the data lives.
Right.
And critically, where the data lives is highly dependent on global geography.
Okay, this is the third pillar.
Yes. The sources are very clear that this execution economy is incredibly fragmented globally. We are moving away from the illusion of a single universal model that rules the world, and we're embracing a multi-model reality.
This stood out to me in the reports. The global maneuvers are fascinating because they prove this is a game of diplomacy and regional strategy, not just computer science. The sources highlight Apple gaining approval for their AI in China, but they didn't do it with their own homegrown model. They did it by partnering with Alibaba's Quinn AI.
Which is a purely pragmatic operational necessity. You cannot just drop a massive Western-trained frontier model behind the Great Firewall and expect it to comply with the heavily audited, localized data regulations in China.
It's just not going to happen. So to participate in that market, you have to use a sovereign compliant model that already plays by the local rules.
Exactly.
And we see this regional execution everywhere in the data. Anthropic is offering localized API pricing in Indian rupees to capture the massive developer ecosystem there.
Smart move.
Meanwhile, China's Moonshot AI just released Kimi 3, which is rapidly advancing their frontier capabilities. The takeaway here is that global expansion requires deep local partnerships.
And that reality is forcing enterprises to build multi-provider architectures. If you are the CTO of a multinational logistics company, your tech stack must be flexible. Well, you have to be able to route your European data to a sovereign-compliant model in Germany, route your internal U.S. coding tasks to a fine-tuned open-source model on AWS, and route your Asian consumer queries to Alibaba's Quinn.
All at the same time.
Right. The orchestration of that multi-model grid is the true competitive moat.
So bringing all these threads together, we've covered the transition to NVIDIA's unified hardware efficiency, the board-level ROI, demands and fine-tuning happening at GitHub and Hugging Face.
Right.
The workflow integration unlocked by MCP, and the complex geopolitical chess game of multi-modal regional partnerships.
It's a lot to take in.
It is. So if you are a listener heading into a strategic planning meeting tomorrow, how do you apply this? Based on this stack of sources, I want to distill this down into a concrete playbook.
Okay, based on the July 2026 intelligence, there are 3 absolute executive directives you must internalize to survive this shift.
Right, directive 1.
Shift your entire operational strategy from isolated experimental pilots to enterprise-scale process redesign.
Stop handing out software licenses and hoping magic happens.
Exactly. You have to actively redesign your business workflows around the capability of the AI.
Measure the cholesterol, not the gym memberships. I love that. Directive 2.
Treat compute bandwidth and data integration as strategic, long-term business investments, not just IT expenses.
Right.
Your ability to compete in the next 5 years depends directly on how efficiently you can deliver intelligence per dollar and how securely that intelligence connects to your proprietary data through protocols like MCP.
Build the superhighway, not the dirt road. And the final directive.
Build governance, security, and responsible AI guardrails directly into the daily operational workflows. Do not treat them as separate compliance chores that happen after the fact.
Like an afterthought.
Right. Security and alignment, like those customizable internal code reviews we talked about, they must happen automatically within the work itself.
It is a phenomenal blueprint for navigating the transition. If you take one overarching thought away from our deep dive today, let it be this. The next chapter of artificial intelligence will not be defined by who builds the smartest systems in a laboratory.
No, it won't.
It will be defined entirely by who operates them most effectively in the real world.
And while optimizing those business workflows is the immediate challenge, the horizon line's detail in the sources suggest an even more profound disruption coming.
Ooh, tell us about that.
Well, the execution economy is currently confined to our screens, our cloud servers, and our code repositories. But the intelligence we are optimizing is preparing to break out of the digital box entirely.
What do you mean?
The sources point toward two frontiers that will completely rewrite our physical reality. The first is ambient computing.
Ambient computing.
Yeah, a world where AI is seamlessly woven into the physical hardware of our environments. It won't be an application you open or a prompt you type. It will be a persistent, context-aware layer of intelligence that anticipates intent and acts autonomously on your behalf.
Is living in the background. That's wild. What's the second frontier?
The second frontier is AI evolving into a new scientific infrastructure. We are moving beyond drafting marketing emails and debugging code.
Right.
These unified compute grids are becoming the foundational substrate for discovering new biological structures, simulating molecular drug interactions, and modeling global climate interventions.
So once this intelligence perfectly executes our enterprise workflows, it will turn its capacity toward the physical world itself.
Exactly. The question isn't just how we operate the AI anymore. The real question is, what happens when the infrastructure around us begins to operate itself?